Hello everyone, welcome to the second session of Logic Loops, and today we will be discussing about one of the sorting method, which is bubble sort. So in this entire session we will be looking on exactly what is bubble sort, basically what is sorting, why it's needed, its time complexity, space complexity and all those things. So first of all, what is sorting? Sorting is nothing but arranging the numbers in such an order that they are either ascending or descending. That is either in the increasing order or in the decreasing order, we can say. So sorting has a number of methods like quick sort is there, merge sort, insertion sort, selection sort, bubble sort. And bubble sort is the easiest way or easiest method we can do so, but not the quick one, okay. So bubble sort is one of the sorting method where we are just comparing the two adjacent numbers, okay. So let's say that right now I am having here the number of arrays 4, 5, 6, 1, 0 and 7. It's right now in the unsorted manner, right? It's not sorted. So what we are going to do here is, let's say I am taking here one variable I, which is starting from the 0th position. Let me first of all just quickly index this array. This is 2 over here, this is 3, this is 4 and this is 5. Okay, so I is pointing to the first index, okay, that is from 0, and it will iterate through the entire array, that is we can say till the length of this array. So it is comparing the adjacent numbers, right? So let's take another variable for comparing, because we will need two variables to compare with each other, right? So let's take j variable, which will start right after I, okay. So now j is pointing to the first index, that is to the 5, and I is pointing to the 0th index, that is 4. So what we will do here is, we will keep on iterating the numbers, okay. That is I will iterate from 0 to 5 and j will iterate from I plus 1 to 5. So now let's compare. Is 4 greater than 5? No. That means I is in the right position. Now what we will do, we will just increment j by 1, okay. That means j plus plus. So now j will change its position from first index to the second index and j will be pointing to 6 now. Now is 4 greater than 6? No. That means still the array is in the correct way. Now let's increment j again by 1. Now it's pointing to 3, right? Is 4 is pointing to 1 rather. So now is 4 greater than 1? Yes. Now 4 is greater than 1. So what we will do, let me just change the color. Yes. So we will just swap these two values. That is, we will swap this 1 and this 4, okay. So 1 will go over here and 4 will come over here. So now how it will look, let me just erase it. Okay. So 1 will come over here and 4 will come over here, okay. Now again the same way. Keep j on incrementing. Now j will go from here to here. Is 1 greater than 4? Oh yes, 1 is greater than 0. So we will just shuffle both the numbers quickly. Now here it will be 0 and here it will be 1, okay. Again increment j by 1. Now it's pointing to 7. Currently I is pointing to 0 only, right? So I will be compared with j, that is 0 is greater than 7? No, 0 is not greater than 7. So our first iteration is done. That means our first element is sort. Right now this is our sorted array, okay. This part is our sorted array. This gives me a sorted array, okay, this way. Now let's move I by 1. Now let's do I plus plus. So let's increment I by 1. Now I is pointing to 1. Now I will be compared with, that is 5 will be compared with 6, because after all j is pointing to always I plus 1. So j will be pointing to 2. Now is 5 greater than 6? No, 5 is not greater than 6. So increase j. Now is j is pointing to 4, okay. So is 5 greater than 4? Yes, 5 is greater than 4. So we will just shuffle the numbers over here. Here it will be 4 and here it will be 5. Again increment. Is 4 greater than 1? Yes, 4 is greater than 1. Shuffle it. 4 will be here and 1 will be over here. One will be over here. Now is 1 greater than 7? No, 1 is not greater than 7. So now this array is sorted. Okay. Now move again I to this hand side. That is, it's pointing to 6 now. Is 6 greater than 5? Yes, 6 is greater than 5. So shuffle 5 over here and 6 over here. Now is 5 greater than 4? Yes, 5 is greater than 4. So here will be 5 and here will be 4. Let me just rewrite it so that it will be more clear to all of you. So here it will be 4, 6 and 5. Okay. Is 4 greater than 7? No, 4 is not greater than 7. So now this array is sorted. Okay, this much array is sorted. Now 6 is, now I is pointing to 6, I mean to say, and j is pointing to I plus 1, that is 5. Now is 6 greater than 5? Yes. So here it will be 6 and here it will be 5. Okay. Now is 5 greater than 7? No. So 5 will remain here only and we will get our sorted array till 5. Now compare 6 with 7, that is last iteration. So 6 is less than 7. So automatically this whole array is sorted. So I hope you have got the idea that exactly how bubble sort works. It just works in order of I plus 1, j plus 1. Now let's quickly look to its code. So there are n number of ways to write this code. I have given you the 3 ways. The one which is in the comment is also the right one and the one which I have just taught you is also the right one. It's in ascending order for the A sort and descending order for the D sort. Okay. So what I have done over here is, okay, just let me write it again so that it will be more clear to all of you. Okay. So let's take one function called as a sort. Okay, and it's taking one argument as nums, which is the array. Now what I will do is I will just iterate our I and j. So first of all, take one for loop of I in range of length of that num. That means how many numbers are there till that length it will iterate. Okay. Now take one variable swap. Now why I am taking this variable swap, I will be covering up later, but for now just take one variable swap and initialize it to false. Okay. Take the another loop for j in range, and now it will start from I plus 1 always. So I plus 1 comma length of this nums. Okay. So our both loops are ready. Now just we have to compare both the numbers. So if nums of I is greater than nums of j, then in that case we have to just swap the values. So nums of I comma nums of j will contain nums of j comma nums of I. Just changing both the values. And here just initialize or just change the value of swap to true. Okay. Now after the for loop of j ends, that means after this indentation, write one if loop, that is if a condition, if this swap is equal to false, then in that case break the loop. Now why I am taking this I will be explaining later, don't worry about that. Okay. Now just return the variable or return the array of nums. Okay. In this way our function is ready. Now define one nums array which is containing the numbers, okay, let's say 0. Okay, this array is done now. And now just simply call out the function a sort with this nums array. Okay. And now just let's quickly run it up. run it up. Yes, we can see over here, here's the sorted array, we can see. So in this way we can sort the array. Now let me tell you why I have taken this and what is the complexity. Okay, first of all let me discuss about the time complexity of this code. So basically the bubble sort have the time complexity in the worst case O(n) square. Now why it's O(n) square, let me just explain you. Let's say this array is in the descending order. Okay, that means we are having here 7, here 5, here 6 and here 1. Okay, it's completely in the descending order. So I and j both will iterate to n values, right? I will iterate to n, j will iterate to n, and that's why if both will iterate to n number of times, so its complexity will of course be O(n) square, right? Because both are iterating to its maximum capacity. And its space complexity would be O(n) because we are not using any variable, any different kind of array to store the sorted things, right? We are just changing the nums array only. So that's why we are not using any auxiliary space more. So space complexity is to 1. Now let me discuss the best time complexity, okay? And why that swap variable I was using. Let's say the array which we are having right now is, let me take one simple one. Okay, so I am having here 4, 4, 4 and 4. Okay, so right now I am having this array. So in this, as all the numbers are same, how many times you will iterate this loop if I am not using the swap variable? So I will be first of all at 0, then 1, then 2. So it will by default check each and every element though the elements are in the sorted order, right? So it will increase the time complexity. So to decrease that, what we are doing, we are taking one variable as swap. Okay, first of all we are initializing it to false. That means right now no element has been swapped. Okay, so it's initialized to false. Then if in case in the future the swap happens, that means if any element is in the wrong position and the swap takes place, then we are initializing it to true. But in case like we are having here the 4, 4, 4 array, in this case the swap would not occur. So if the swap does not occur, that means if the swap value is to false, then it will automatically break the loop and no more further checkings would be performed. Okay, so in this way you can decrease your time complexity of the bubble sort to O(n). Okay, so I hope this code and this entire lecture will be clear to all of you. Thank you so much for having your attention on this video. Thank you.